You know, the buildings we live and work in every single day, they're up against some brand new, pretty intense challenges from our changing climate. So, what if we had a new instruction manual to help us adapt? Let's take a look at what that might be.
I mean, just think about that for a second. It really gets to the heart of the problem, doesn't it? Basically, everything we thought we knew when we designed our homes and our cities, how hot it would get, how much it would rain, well, those rules just don't apply anymore.
So what does that actually mean for the places we spend our lives? It means that the very blueprints, the core ideas behind how our buildings were made, are becoming outdated, and it's happening fast, almost overnight.
And look, this isn't some far-off 50 years from now kind of problem. We're talking about things happening right now. More extreme heat, wilder winds, way heavier rain, and all of it is putting a real strain on our buildings and, of course, on us inside them.
And it's not just a few architects who are talking about this. The IPCC, the world's top climate scientists, are being crystal clear. We have to completely change how we think about building things. Thinking about climate risk can't be some extra feature you bolt on at the end. No, it has to be baked in from the very first sketch.
Okay, so things are changing fast. We've got all these new threats. Where do you even start? It can feel pretty overwhelming, right? Well, the good news is the European Union has actually put together a framework to help us get a handle on it all.
And what's so smart about this is how it takes all this chaos and makes it simple. They've sorted all the big climate hazards into 4 basic buckets: temperature, wind, water, and what they call solid mass. This gives us a really clear roadmap for what to focus on.
So you've got those 4 categories, but out of all of them, the EU guidance points to one as the #1 priority, the biggest threat our buildings need to be ready for across the entire continent. And that threat? It's heat. Now, when we talk about extreme heat, it's not just about cranking up the AC. The effects can be way more direct and, frankly, pretty surprising. We're not talking about just being uncomfortable. We're talking about the building itself literally starting to fail. And it can all start with something as simple as a window.
So let's really dig into that. Beyond just making it hot inside, what does a heat wave actually do to the physical stuff a building is made of? Well, one of the wildest answers is something called thermal stress breakage. It's a really fascinating thing. This isn't a baseball hitting the window. It's not a defect in the glass. The glass literally shatters itself just because of a sudden, intense change in temperature across its surface.
So here's how it happens. It's actually pretty simple physics. Step 1, the sun beats down on the middle of the glass, making it really hot. Step 2, as that middle part gets hotter, it wants to expand. That's just what materials do. But here's the catch. Step 3, the edges of the glass, tucked into the cool, shady window frame, stay much cooler, so they don't expand. So you've got the middle pushing outwards and the edges holding it back. That creates an insane amount of stress, and pop! The glass just cracks.
And you can actually tell when this has happened. It's not that classic spiderweb shatter pattern you might be thinking of. Nope. It's this really clean 90-degree crack that always starts right from the edge of the glass. It's like a signature, telling you exactly what happened. Okay, so that's a wild story, right? A window that breaks itself. But if we can get our heads around a problem that specific, we can start to see how to solve the much bigger problem of an entire building overheating. The same ideas just get scaled up.
So, how do you take the solution for one window and apply it to a whole building? Well, for that single window, the micro level, the fix is pretty technical. You use special heat-treated glass, you run some analysis, but for the whole building, the macro level, we just apply that same thinking. We manage the sun's heat with things like exterior shades or green roofs that actually cool the surface. And even something as simple as using light-colored reflective paint can make a huge difference.
The main takeaway here is that we actually have a whole new toolkit to deal with this hotter weather. We're talking about things like green roofs, which don't just sit there, they actively cool the building. Planting more trees for natural shade, designing for better passive ventilation, and like we said, even just choosing light-colored walls to reflect the sun is a game changer. It's all about working smarter with nature, not just building a concrete box to fight it. You see where this is all going, right? This points to a massive shift in how we think. We can't just keep building the same old buildings we've been putting up for decades and just, hope for the best. We have to start designing and building for the world we're actually living in today.
And this right here, this is the goal. This is the future we're trying to build. A future where our buildings aren't just concrete bunkers trying to fight off the weather, but are actually smart, active systems designed to work with their environment.
So, when you boil it all down, the real question we have to ask ourselves is this: how do we redesign everything? Our homes, our offices, our entire cities, so they're not just vulnerable targets for a changing climate, but resilient partners that can handle whatever comes their way. It's a huge challenge for sure, but man, it is also one of the greatest and most exciting design opportunities of our lifetime.